Hello everyone, this is ToothSense and this was our summer internship project for the AICTE Idea Lab. So basically what we wanted to make was a AI powered detection software where users can come and upload their image and they can get the disease prediction and detection using AI models, and they can also get suggestions on how to improve on their condition. So for implementing this, we first had to gather a data set. So for the data set, we are using two types of data sets. The first data set is the X-ray panoramic data set. This data set is having all these classes and it's using a YOLO V8 model for classification. And you can see all the diseases that it classifies. And these were the type of images that were available in the data set. After that, the next data set we had was the oral disease detection data set. In this data set, we had images of actually people's mouths, which they took themselves or in a clinic. So these are not X-ray images, but just normal images. So it also detects multiple diseases, and all the classes are mentioned here. You can see it detects calculus, data caries, gingivitis, mouth ulcer, etc. So this was the dataset we trained our ResNet 50 model on, and it classifies whatever disease it thinks is best. So after collecting the dataset, we had to do the coding part. So in the coding part, we are using Flask as our backend server. Here you can see the file. We are loading all the models here, and we have defined API endpoints. I'll just show you the endpoints. Yes, here you can see it has the analyze X-ray endpoint. So this is when the user in the front end uploads the X-ray image, and then we also have the analyze gum root. This is what is used when the user uploads a gum image. And for the front end, we have used React and TypeScript. And now I'll proceed to show you the demo of the project we made. So here you can come and see all the guidelines for image uploading, and then you can choose your image. I have this image right here, and then it takes some time to run the model on the backend. It's taking a bit longer because the model is deployed on our custom backend and it's kind of resource limited for now. But we can improve these times of inference significantly in the future. It also supports multilingual, so at any time you can change the language of the interface and it will just change the language. So here you can see it has given us the directions. So you can see this is the YOLO bounding boxes, which the classes I showed you earlier in the dataset. So this will be very useful. You can identify where and what all diseases your X-ray displays. Here you can see the index, that purple is implant, blue is filling, green is crown, and you can see where all those issues are. And then when we come down, it's showing a high level risk, and it's showing all the detections it had, and it's also giving treatment recommendations. It also allows you to download a simple report, so you can just download the report. Here you can see it tells you the disease it detected and the description and treatment recommendations. And for the gum image route, I'll just show you. Mm, yes, here you can see we have the gum images, so I'll take this image. This is using the ResNet 50 model for classification of diseases. So as you can see, it detected the diseases calculus, and it's giving the description and treatment recommendations as I showed you earlier. So this was basically our implementation of the dental disease detection. In the backend, it's using YOLO and ResNet 50. These were the models we had custom trained. And if I would like to show you the training also, the training was done on Google Colab. So here it was where we trained our models, and it will also show you the training accuracy and the training quality. You can check. I'll just show you the results. If yes, you can see we had trained the model for 50 epochs, and this was the result. It was a pretty accurate model, and we had achieved an accuracy of 86% in the resonant model. And we had also added augmentation in the images. That's why the accuracy is a bit low, but the accuracy for the YOLO model is near 96%. So it was the ToothSense project, and thank you for listening me out.